Hello everyone, welcome to our presentation today. My name is Jing Luo, and I'm a PhD student from University of Pittsburgh. First, I want to thank for the invitation to this session. Our topic today is Should I Stay or Should I Go? Behavior Response to Incentive to Leave a Queue. This is a joint work with Professor Linardi and Professor Valdez. It is partially motivated by the current pandemic, COVID-19. Also, I would like to mention that our study is still in progress, and what we will show you today is the design and the result of a pilot study. So we are looking forward to any comments and questions. And this is our agenda today. First, let's start with our motivation. The ongoing pandemic tremendously limits our daily activities, and the government requests the stay-at-home order. However, we must get our living necessities for our family. So this thing is quite common now. People in this image are waiting in lines to get into the grocery store. Lots of people came at once, so they have to wait hours to get their needs. During this long waiting in lines, people have to stay in this high-risk environment with wearing a mask for a long time. And it made the customers tired and stressful. Also, another article from New York Times in April mentioned that because of COVID-19, similar long lines are also observed in other places like voting stations, food banks, social service centers, etc. Thus, the problem is that too many people are waiting in the line for the service. In addition to the problems specific to COVID-19, we also see similar congestions in other contexts like bus stop, retail stores, public housing, etc. So this question is how to solve this problem? Is there a possible solution? And this is the answer from Build-A-Bear. In 2018, Pay Your Age event attract too many people, and some people takes more than 5 hours to get their fluffy toys. To reduce the queue length, the company offered discount coupons to try to incentivize some people to leave the queue. Therefore, the big question is to smooth the traffic in the congestion scenarios. But to solve it, we first need to study how people respond to monetary incentives to leave or not join a queue. To simplify, the story can be like this. A number of people lined up waiting for the service in the store or bus stop. We try to use monetary incentives to make them leave the queue. Then we were thinking, why not give the incentive earlier, like when this person is still at home? Similar to transportation literature, some cities have studied offering cash incentive for people to leave during off-peak hours. Thus, the question is, will it be cheaper to incentivize people earlier? Also, whether the timing of incentive during the waiting impact people's behavior. So the first research question is, how do people respond to incentive to abandon a queue? Will the timing of incentive impact people's decision to abandon or not join a queue? Will queue characteristics like value of the service, queue length, and speed impact people's behavior? If so, how? To the literature first, the literature of smart city and transportation has studied the use of incentive to mitigate traffic problem. Also study on dynamic price discussed about peak price in the high demand period. However, they do not take into account the characteristic of a queue. On the other hand, we also draw from literature of behavioral queuing, particularly on the topic of abandonment. It has been shown that from General Camp's finding, there are many two forces driving people's abandonment behavior in pure waiting, which are waiting disutility and completion utility. The other two listed behavioral queuing papers tell us that during waiting in the queue, people make decisions on different queue characteristics like queue length, speed, position in the queue, etc. However, this literature has not studied the incentive to leave a queue. So with our experiment, we fill this gap with investigating people's abandonment behavior in the queue with outside incentive. Then for the experimental design of the pilot, we have between subject treatment for join and renege condition. Also, we have within subject design for 10 queues for each subject. Every queue has various number of queue length store points that denotes the rewards that they will get if they get to the store, and outside points, which is the incentive to leave the queue. Our pilot has a design of single-player task where each participant interacts with a computer-simulated store queuing environment. We conduct an online experiment on Amazon Turk to test our hypothesis. And it is designed to mimic the practical queuing scenarios that subjects are familiar with in their daily lives. Subjects are asked to imagine themselves as customers and to make a decision on an animated queue with a number of virtual customers in front of a store, where there's only one virtual customer being serviced inside the store. The experiment is designed in two conditions, and this is the join condition. The subjects will be only assigned to one of the join and renege condition. Subjects are placed outside the store queue and asked to decide whether to join this queue or not. Where in renege condition, all steps remains the same as the join condition, except subjects automatically join the queue and decide whether to abandon it or not. Also, to capture a queuing scenario in an online study and to prevent participants from performing a different task on their computers while completing the line, they must click to move forward until they reach the store whenever a virtual customer in the front moves one step ahead. But if the subjects do not decide to wait in the random selected queue, they will proceed to next queue directly. Then we also have various parameters for characteristics of the 10 queues. With the same sums rate for all queues, we first start with a queue length that represents the number of virtual customers in a line. In this task, queue length is started in 2 levels, short in 8 and long in 13. Second parameter is the store points. That is the bonus payment they will get if they choose to join the queue and get to the store. It is started in 2 levels, large in 45 and small in 30 points. The last one is the outside point. That is a bonus payment that represents the incentive to not be in the queue. It is set in 3 levels, high in 30 points, low in 15 points, and 0 points, where 0 means there is no incentive to leave. And in each queue setting, we make the outside points always smaller than the store points. The experiment follows the same procedure for all subjects. First, there is a participant, and there is a practice section for the task. Then all subjects are required to complete 10 queues. Then subjects proceed to 2 lotteries on risk preference and time and consistency. At the end of the study, there is a survey for all subjects. For now, we only have the result for the pilot. And for the pilot, we have 100 subjects. The average time for all participants is about 23 minutes. And the conversion rate in our experiment is 20 points to $1. So first, for the result in our pilot, we observed that there is no significant difference between these two conditions. However, we do not think this is necessarily there is no difference in timing. We will go to this at the end, why we think this may have happened. But we see that 52% of the subjects do change their decisions based on the incentive during the 10 queuing decisions. Well, for the outside incentive, we see a decrease from 73% of people in deciding to join or stay in the queue to 62% because of offering the outside incentives. And we ran regression analysis to study our data, but in the interest of time, I'm going to show you the same result with some graphs. So let's look at how people behave in short queues. For each of the bars, we have the store points on the top, high store points and low store points. For each value of the store points, we have different value of outside points on the bottom of x-axis of incentive to leave. The y-axis we are showing is the percentage of subjects of join or stay, where we combine the result of join and renege condition because we see the same patterns in both cases. So the red line is quite flat except the 30 outside incentive to leave in 45 store points. People do not react to incentive unless it is a high value of outside incentive in the high store value. When the queue is long, subjects are more sensitive to incentives. From the two red stop lines, we see that with the increase of outside incentive to leave, people are less likely to join or stay in the line in both store points. Comparing with the short queues, other parameters like 30 store points and 15 outside incentive to leave also have an impact. This is more in line with what would be expected. This behavior is observed in both join and renege conditions, and it leads to what we think is the punchline for both short and long queues, is that when the queue is long, people join or stay in line significantly less often when 30 outside points and 45 store points than 15 outside points and 30 store points, even though in both cases the difference in points is the same at 15 points. But the difference is not significant anymore when the queue is long. The reason why we think this is a possible punchline of pilot study is that in a queue scenario with incentive to leave, people pay more attention to outside incentives than service values. And this behavior interacts with queue length, that the disproportional attention to outside incentive to leave happens in short queues, but not significant in long queues. So to summary, first, we do not observe any significant difference between the renege and join conditions. Then we see that incentive does decrease the likelihood queue, but there is heterogeneity among the subject's behavior. And people react differently to incentives in short and long queues. So regarding the first result, we know that in real world, people in the join and renege condition may be in very different decision-making environments. But in order to capture clearly the difference between the two, we start with a very minimum manipulation of whether the dot for U is placed inside or outside the line. Our pilot suggests that this is not enough. And we are going to first, we are going to improve the realism of renege condition in our study for the next step. First, we will ask subjects to choose the queue and then ask them to renege or not. So the subjects will have a more or like a stronger feeling of that being inside the queue. Also, we are going to vary the number of minutes the subjects wait before offering the incentive to leave. So that is all for our presentation today. Thank you for listening, and we are very welcome and looking forward to your comments and questions. Thank you.